Hi, Mr. Sapone here, and today I'm bringing you a video on dot diagrams. We're going to learn how to write Lewis dot structures. And what exactly is a dot structure? Well, dot structures are going to be used to represent valence electrons. And recall that valence electrons are electrons in the outermost energy level of an atom. So if we have a diagram, like we do over here, a Bohr diagram for sodium, it represents electrons by energy level. Sodium is number 11 on the periodic table. It has 11 protons and also 11 electrons if it's neutral. And they will fill up the atom like this: 2 in the first energy level, 8 in the third, or 8 in the second energy level, 1 in the third. So valence electrons are electrons in the outermost energy level. This is the outermost level right here. And as it turns out, sodium only has one valence electron. There's one electron in its outermost energy level. That's what a valence electron is. So we're going to draw dot diagrams which kind of simplify these slightly more complicated Bohr diagrams. Understanding valence electrons and dot diagrams is very, very important for bonding. Valence electrons are going to be super, super important. And we're going to look at a little trick for drawing them. We're not going to have to draw a Bohr diagram in every case and then count the valence electrons. There's going to be a very simple trick. So if we look here at the periodic table is labeled. There are 18 columns on the periodic table. It goes from 1 all the way over to here, which is 18. 1 through 18, there's 18 columns, but we also sub-label the periodic table. This is called 1A, 2A, and we kind of skip all of this. 3A, 4A, 5A, 6A, 7A, 8A. And these elements in columns 1A through 8A are called the representative elements. So all of these, 1A and 2A, we skip all the stuff in the middle. 3A through 8A, these are all considered the representative elements, and they are sub-labeled columns 1A through 8A. And that's going to be important. Column number 1A through 8A is going to indicate the number of valence electrons. Recall that we just looked at the Bohr diagram for sodium. Sodium had one valence electron. Sodium's in column 1A. That means all of the elements in this column are going to have one valence electron. Hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, they all have one. All of the elements in column 2A, they have two VEs. And the trend continues. Again, we ignore all this stuff. These aren't the representative elements. But when we come over here, column 5, nitrogen's going to have 5 valence electrons because it's in column 5A. 6, 7, and 8. And this is kind of why the periodic table has this weird shape. Notice all this space is missing in here. Why is the periodic table shaped like this? Why is it not a perfect square? Why isn't helium over here and we just go in order? Well, the periodic table is shaped so that there's a repeating pattern in electron configuration. It goes in order of increasing atomic number, proton number, 1, 2, 3, 4, 5, 6, 7. But we kind of shape it and separate it so that way there's a repeating pattern in the electrons as well and how they are configured. So now we're just going to draw some dot diagrams, and we're going to go from lithium to neon. And recall that lithium is in column 1A, so it has one valence electron. What we do is we draw the symbol of the element, lithium. We start on the right and we move like a clock. Lithium has one valence electron, so I'm just going to put one dot around it. That is it. It's that simple. Now if I go to beryllium, beryllium has two valence electrons. So I'm going to draw one dot here. I'm going to move like a clock. We're going to do a four corners kind of thing. Beryllium. Now I'm going to go to boron. Boron has three valence electrons. So 1, 2, 3. Next, we're going over to carbon. And carbon has four valence electrons. It's in column 4A. 1, 2, 3, 4. So we kind of have a four corners things or like a plus going on here. Now what happens when we get to nitrogen? Nitrogen's going to have 5. So I'm going to go 1, 2, 3, 4. And now I'm going to double up over here. And as we go on, we're going to do the same thing. We're going to keep doubling up. So oxygen has 6 valence electrons. 1, 2, 3, 4, 5. Doubled up again. 6. Now we're going to draw fluorine. And same thing. 1, 2, 3, 4, 5. Oh, sorry. Let me go around. 1, 2, 3, 4, 5, 6, 7. That's a little bit messy. That one, I'll draw the next one neater. And let's go over to neon. Last column, last one. Neon has 8 valence electrons, column 8A. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So 2, 2, 2, 2. So valence electrons are just going to be represented by these dot diagrams. If I drew this carbon, it's just telling me that there's 4 valence electrons. And these diagrams are going to become important when we do bonding. We're going to see how valence electrons transfer from one element to another. So all you got to do is look at the column number, 1A through 8A, and put that many dots around it. And generally, we want to start on the right, move around, and once we get around, we start doubling up. Hopefully you can draw dot diagrams now. You have a brief assignment. Draw dot diagrams for silicon, aluminum, calcium, potassium, sulfur, iodine, phosphorus, and argon. And again, use that rule. Column number is the number of valence electrons. Start at the right and move around. Hopefully you have an understanding of dot diagrams. This is Mr. Stapone. I'm out.